Somewhere behind your sternum, a molecule the size of nothing is dissolving into your bloodstream. You won't feel it. There's no warmth, no tingle, no sudden surge of strength. You'll swallow the water, set the glass down, and go on with your morning as if nothing happened at all. But 3 feet below your throat, inside a muscle fiber you've never consciously thought about, something is already changing. A negotiation is beginning between your cells and a compound that has existed in your body since before you were born. Most people think creatine is something you add to your body. A supplement. An outside substance entering foreign territory. That's not quite what's happening. The molecule that was already there. Here is the part almost nobody explains before selling you a tub of white powder. Your body already makes creatine. Your liver, kidneys, and pancreas synthesize roughly 1 gram of it a day, quietly, without instruction, using 3 amino acids most people couldn't name. It travels through your blood and lodges itself primarily in one place, skeletal muscle, where it waits. It waits for a very specific kind of emergency. Not the emergency of a marathon. Not even the emergency of a long run. The emergency creatine exists for lasts somewhere between 1 and 10 seconds. The first violent pull of a barbell off the floor. The first explosive stride out of the blocks. The moment your body demands more energy than its normal systems can produce fast enough, and something has to answer that demand immediately, with no time to breathe, no time to burn sugar, no time to wait for oxygen to arrive. That something is a molecule called ATP, adenosine triphosphate, the actual currency your cells spend to create movement. Every contraction, every twitch, every microflex of a fiber costs 1 unit of ATP. And here's the uncomfortable part. Your muscles only store enough ATP to last about 2 seconds of maximal effort. 2 seconds. After that, your body needs to manufacture more ATP on the spot, faster than it can be delivered by any other system. This is where creatine, technically, phosphocreatine, its stored form, steps in. It hands off a phosphate molecule almost instantly, regenerating ATP within a fraction of a second, buying your muscle just enough time to keep moving before the slower, oxygen-dependent systems can catch up. In other words, creatine is not what makes you strong. Creatine is what keeps you moving in the silence before your body figures out how to be strong. The first 15 minutes. So what happens after you swallow it? For the first few minutes, very little. The compound sits in your stomach, gets absorbed into your small intestine, and enters circulation. Blood creatine levels begin rising, but here is where the popular myth quietly falls apart. Most people assume creatine works the way caffeine works. It hits your bloodstream, and within minutes you feel something. A jolt. An edge. Researchers who study muscle transporters will tell you that's not how this molecule behaves at all. Because creatine doesn't diffuse into muscle cells on its own. It needs a doorway, a specific transport protein called Creatine, embedded in the membrane of your muscle fibers, whose entire job is to physically escort creatine molecules from the bloodstream into the cell. And this transporter is slow. Selective. Almost reluctant. It doesn't fling the doors open. It works 1 molecule, 1 negotiation, at a time. This means that 15 minutes after ingestion, you are not full of creatine. You are, biologically speaking, barely at the beginning of a process that, for full muscular saturation, can take anywhere from several days to several weeks of consistent intake to complete. There is no lightning bolt. No switch flipped. What's actually happening in those first 15 minutes is closer to a bureaucratic process than a chemical explosion. Transporters quietly working, molecule by molecule, moving a resource into long-term muscular storage for a moment that hasn't happened yet. This is the part that unsettles people once they understand it. The compound isn't doing anything for you today. It's making a deposit for a version of you that doesn't exist yet, the one who will need it during the 11th rep, next week, or next month. The water you didn't know you were holding. There's a second process happening in this window, one that explains a phenomenon almost every first-time user notices and misunderstands. Creatine is osmotically active. Wherever it accumulates inside a cell, it pulls water in after it, through simple osmotic pressure, the same physical law that makes a raisin swell back into a grape when soaked in water. As creatine slowly loads into muscle fibers over the coming days, those fibers begin holding measurably more intracellular water. Most people interpret this as bloating, or worse, as fat gain. It is neither. What's actually happening is that the muscle cell itself becomes more hydrated, from the inside, not the outside, not under the skin. And this matters more than it sounds like it should, because researchers studying cell physiology have found that cellular hydration status itself acts as a signal, a trigger that influences whether a cell leans toward building tissue or breaking it down. A more hydrated cell behaves, chemically, like a cell that senses abundance. A dehydrated cell behaves like a cell bracing for scarcity. Which means the water isn't just a side effect of creatine. It might be part of the mechanism. The swelling isn't incidental. Some researchers believe it's a quiet biochemical message, whispered to the machinery inside the cell: you are not in a crisis. You can afford to grow. The myth that refuses to die. Ask 100 people what creatine does, and a striking number will say some version of the same sentence: it's basically steroids, just legal. This assumption has survived for over 2 decades, and it collapses the moment you look at what actually happens at the molecular level. Anabolic steroids work by binding to androgen receptors inside cells and directly altering which genes get switched on, rewriting, in a sense, the instructions your DNA is currently following. It is a hormonal intervention. Creatine does none of this. It never touches a hormone receptor. It never enters the nucleus. It never rewrites a genetic instruction. It is not a hormone, a steroid, or a drug in the pharmacological sense at all. It is closer to a fuel buffering system, a logistics upgrade for a process your body was already running. The confusion isn't entirely irrational, though, and this is where it gets interesting. Because the outcome of consistent creatine use, more explosive strength across repeated efforts, incrementally more training volume, and yes, more water-supported cell volume, can visually resemble the effects people associate with performance drugs. The resemblance is real. The mechanism is not even close. This is one of the strange truths sports scientists keep running into: the body doesn't need a foreign hormonal command to change dramatically. Sometimes it just needs slightly more raw material to keep doing, a few seconds longer, what it was already trying to do. Why your brain might care more than your muscles. For most of its research history, creatine was studied almost exclusively as a muscle compound. That assumption is now being quietly dismantled. The human brain, it turns out, consumes an extraordinary, disproportionate amount of energy relative to its size, and during moments of mental fatigue, sleep deprivation, or high cognitive load, brain tissue faces the exact same ATP bottleneck that a sprinting muscle does. Some researchers investigating cognition under stress have found that creatine supplementation appears to support mental performance during conditions of fatigue or sleep loss, likely through the same phosphocreatine energy buffering system operating in neurons instead of muscle fibers. This finding, still actively debated, still being replicated across different labs, quietly reframes everything. If true, it means creatine was never really a bodybuilding supplement that happened to have side effects. It may be closer to a general cellular energy reserve system, one your body deploys anywhere ATP runs out quickly, fast-twitch muscle during a sprint, or an exhausted brain during a stressful, sleepless week. The same emergency reserve. 2 entirely different battlefields. The placebo inside the powder. There's one more layer researchers have had to reckon with, and it's the most psychologically uncomfortable of all. In several controlled studies where participants were given a placebo but told they were receiving creatine, measurable performance improvements still showed up. Not identical to the real compound, but real, and not nothing. This doesn't mean creatine doesn't work. The physiological mechanism is well documented and consistently replicated. What it means is something stranger: that belief itself alters how much force a nervous system is willing to permit a muscle to generate. Expectation appears to raise the ceiling your brain is willing to allow your body to reach. Which raises the uncomfortable question sports physiologists still haven't fully answered: how much of any performance improvement, from any intervention, is the molecule, and how much is the mind quietly giving itself permission to stop holding back? What 15 minutes actually means. So return to that moment. 15 minutes after swallowing it. A transporter protein, unhurried, ushering molecules across a cell membrane one at a time. Water beginning to follow. No hormone touched. No gene rewritten. No dramatic surge of anything. It would be easy to call this anticlimactic. It might be more accurate to call it honest. Because almost nothing that meaningfully changes the human body happens in a single dramatic instant. Not muscle growth. Not fat loss. Not endurance. Not the rewiring of a habit. The pattern researchers keep finding: across nearly every system they study, muscular, neurological, metabolic, is the same one playing out quietly in your bloodstream right now, small, unglamorous, repeated deposits, made long before the moment they're needed, compounding into something that eventually looks, from the outside, like transformation. We tend to want the dramatic version. The switch. The jolt. The single decisive action that changes everything. But the body, it seems, was never built to work that way, and maybe that's the more unsettling realization sitting underneath all of this. If your muscles run on reserves built days in advance, without your awareness, without your permission even required beyond the choice to keep showing up, what does that say about everything else we assume happens in the moment? Discipline. Willpower. Even the vague, comforting idea that we are always fully present for the changes happening inside us. 15 minutes after you take creatine, almost nothing visible has occurred. And somewhere, quietly, that might be the whole point.